Hello friends, welcome back to the channel. In this video, we solve an interesting thermodynamic problem involving an ideal monatomic gas heated along two paths, that is AB and AC on PV diagram, and we have to find the ratio of heat transfer in these processes and explain every step very clearly. So let's get started. Okay, so let's first understand this problem. We are given a PV diagram here. This is pressure versus volume. AB is one process where the pressure is constant, that is isobaric process, and AC, that is a diagonal path where the pressure and volume both increases if you move from A to C, right? But one more thing we have given, that both B and C temperatures are equal. Okay, so delta T in both the cases are equal because temperature of B and temperature of C are equal. One more information, the gas is monoatomic. Now let's figure out heat in different processes. So to calculate heat for this process AB, okay. So first let's calculate in the heat that is exchanged in AB process, right? Okay. So we can say just QAB, since it is isobaric process, that will be NCP delta T. Very simple. Now it is monatomic gas, it will be Cp equal to 5R by 2, as we know that. So it will be, and moles is 1, so 1 into 5R by 2 into delta T. Okay. Let's figure out AC. AC is a polytropic process here, right? And for that equation we can write it as pressure equal to some constant K into V. Why? Because it is a straight line passing through origin, so we can just write Y equal to mx. So here we can write PV minus 1 equal to K, that is constant. So polytropic index, that is X, is equal to minus 1. Okay, polytropic process, what we say, PVX equal to constant, where X is polytropic index. So this is what polytropic index, X equal to minus 1. Now here we will find molar heat capacity, that is Cm, that is equal to Cv plus R divided by 1 minus X, where X is polytropic index, so it will be Cv plus R by 1 minus 1, that is Cv plus R by 2. Now, since it is a monoatomic gas, right? So Cv for this process is 3R by 2, so it will be 3R by 2 plus R by 2. Overall it will become 2R. Now QAC we can calculate, that will be N Cm into delta T. N is 1, Cm value is 2R into delta T. Now we'll figure out final QAB by QAC. That it will be 5R by 2 delta T divided by 2R into delta T. Delta T cancel out, R cancel out. It will become 5 by 4. Okay. Now they are asking you the value of this multiply with 10. Okay. But they are asking you QAC by QAB. Okay. So QAC by QAB into 10 will be equal to just reciprocal of this, 4 by 5 into 10, and that it will be equal to 8. So that is the final process. So AB is just the, what we can say, isobaric process, and this is a polytropic process. And these are the heat involved in the two path ratio. So that's all. Thank you.